Anyone?
I saw that you made a correction on the test date. So is it not happening this Saturday?
Yes, because I didn't take into account that some of you would celebrate even Saturday and Sunday Easter, and it was my mistake, so I had to move it. So sorry. Any questions?
I do have a math-related question.
Please do.
A web assignment question.
Yes, please.
It is from section 4.1.
Yes.
And at least for me, it was question 10. But find the critical numbers of the function. And then it was, t to the 3/4 minus 6t to the 1/4. Correct.
Critical numbers, very good. Great job. So remember, critical numbers come from two possible sources. Either f prime of x is 0 or f prime of x is undefined, but the function must be defined there. So I know that this function can be rewritten because this is the index 4. And because the index is 4, which is even, the quantity under has to be greater than or equal to 0. So in this case, t must be greater than or equal to 0. T cubed, if I write t cubed greater than or equal to 0, I will still have t greater than or equal to 0. So the domain of function f is indeed the 0 to infinity. I need this because I may have a critical number coming from f prime undefined, and I still have to know whether the function is defined there. If it's not defined there, there is no critical number. If it's defined there, it's a critical number. Okay, perfect. So now let's differentiate. I'm not going to differentiate this. I'm going to differentiate that. So f prime of x is, bring down 3/4, t to power 3/4 minus 1, which is negative 1/4, minus 6 times 1/4 times t to 1/4 minus 1, which is negative 3/4. Thank you, Sean. It's an ugly problem. I'm kidding. It's still ugly, but I'm not saying it's fine. We have to see things like that. I would have chosen one anyway. So, okay, so I see 3/4. The 4th root of t minus 6/4, but the 4th root of t cubed. Let's look at this for a moment and let me know if this is clear.
Is it possible to move the paper up a little bit?
Oh, yes, yes. I'm sorry. Of course. The least common denominator, oops, what's this? The least common denominator obviously is 4, the 4th root of t to the 3rd. So I need to multiply the numerator by the 4th root of t squared. So let's look at this for a moment. Please tell me if you have any questions. I don't want to move on. If you have questions, please. Is everything okay so far?
Yes, so far it is.
Perfect. So then I have 3, the 4th root of t squared minus 6. Now I'm looking at critical numbers. I set it equal to 0 and I see whether it's undefined. Is this ever undefined? It will be undefined at t equals 0, and it will be undefined when t is less than 0 as well. But that's not the case, because the domain is 0 to infinity, so I cannot even talk about less than 0. But it could be undefined, and it will be undefined when t is 0. I have 0 in the denominator. Is the function defined at 0? If you say yes, then I will say t equals 0 is a critical number. If you say no, then I will say t equals 0 is not a critical number. See why I have to determine the domain? So yes, t equals 0 is a critical number because the derivative does not exist there, but the function does. The next possible situation is when f prime of t, I just realized something, sorry, f prime of t is 0. A fraction is 0 when the numerator is 0. So 3, the fourth root of t squared minus 6 is 0. I will divide both sides by 3, and I get that the fourth root of t squared equals 2. The fourth root of t squared is the same with t to 2 over 4, which is the same with t to 1 over 2, which is the same with the square root of t. Since this equation is identical with this equation, I would rather solve this and square. So then t equals 4. But I have to make sure that, first of all, it's in the domain. Yes, it is. And I have to make sure that this is 0, right? 4 squared is 16. The fourth root is 2. 3 times 2 is 6. 6 minus 6. I have to check. Every time I raise to a power, I have to check the solution. So it is correct. So this is the second critical number. Very interesting problem, Sean. Thank you. You always do that to me. Very good. So this function happened to have critical numbers, two critical numbers, one coming from f prime being 0 and one coming from f prime being undefined. From f prime being undefined, we have t equals 0, and from f prime being 0, we have t equals 4. Great problem. Thank you. Next question. Yes, Sean, is this okay?
Yes, it is. Thank you.
Thank you. Next question. Anything? Anyone? Anything? Okay, I would like to look at another problem with the mean value theorem on page 289. A problem that I did last night with my students. I thought it was interesting. Problem 24. Suppose that 3 less than or equal to f prime less than or equal to 5 for all values of x. Show that this happens. Okay. So 3 less than or equal to f prime of x less than or equal to 5. Very important statement, all x. In other words, the derivative exists for everything and it's bounded. Bounded below by 3, bounded above by 5. Show this. Okay.
Down a little.
Yes, sorry. Okay. So here's what we learn from this information. Number one, that since the derivative for all values of x is between 3 and 5, obviously the function is continuous everywhere. Number 2, f is differentiable everywhere. So it says for all x. These two are the hypotheses of which theorem? Mean value theorem. So from 1 and 2 by MVT, I will always find at least one C in the open interval, and we'll decide the interval in a moment, such that f prime of C, let me write a comma b. F prime of C equals f of b minus f of a over b minus a. This is clear because every time I show that the function is continuous and differentiable, I have to find at least one C in any interval that I need, such that f prime of C is fulfilling the condition f prime of C equals f of b minus f of a over b minus a. And now I go back to what I need to show. Can anyone identify an interval with which we should start our work? By comparison, I see f of b as f of 8 and f of a as f of 2. So my pick of interval would be that C belongs to, can anyone tell us?
Two.
Very good. Comma?
8.
That's it. Good. So I know that f prime of anything, including f prime of C, is bounded between 3 and 5. So now I know that between 3 and 5, I have f of 8 minus f of 2 divided, obviously, by what?
A minus 2.
Of course. So therefore, I perform the operation in the denominator. I get 3 less than or equal to f of 8 minus f of 2, everything divided by 6 less than or equal to 5. I'm much closer to showing the relationship, but I have one more step left, one more step to go, which is what? What should I do?
Multiply everything by 6.
That's it. Done. Any questions here? Questions? Okay. I think we can continue. We talked about increasing, decreasing. We talked about the first derivative test. We're going to talk about the second derivative test and then work on problems. Ready? Okay. Problems 9 through 18. Find the intervals on which f is increasing or decreasing. Find the local max and min values of f. Find the intervals of concavity. This is our next step. So for now, part A and B, and then I'll explain part C and what they're asking us to do in part C. Would you like to start with a polynomial? Would you like to start with a rational function? an exponential function, a combo. You want to start with a polynomial then? Any preference? No preference? Okay, I'm going to start then, let's say, with number 10. And this is a polynomial function. So this is our section 4.3. We are talking about here about the effect of derivatives on functions. So what do we learn from derivatives? First and second derivative information about a function, about, let's just say, f of x. This should be the title of section 4.3. Okay, 10 on page 280, I'm lying, 298. We're given a function which is f of x 4x cubed plus 3x squared minus 6x plus 1. And I need to put this book away because it's just so heavy. Find intervals of increasing, decreasing, and local maximum. Oh, good. Okay, so let's start with our table, in which I recommend put the first derivative first, the function in the middle, and yes, this time we are going to add one more row. The last one, I promise, there is no additional row. The second derivative, and we'll talk about it. I know this function is polynomial, so its domain must be negative infinity to infinity. I'm hoping that it has, and it has to have, it's cubic, so it has to have at least 2 terms. I mean, the maximum possible 2 terms. So I know I'm going to find critical numbers, no question there. No critical numbers will come from f prime being undefined, not possible. And when I determine f prime, I get 12x squared plus 6x minus 6. And critical numbers, and I expect 2, will come from this, from solving this equation. So then we have 12x squared plus 6x minus 6 equals 0. Of course, I will divide by 6. And I get 2x squared plus x minus 1 equals 0. And I'm hoping that it will not take us long to factor this. And when we factor it, we get 2x minus 1 and x plus 1. So let's check. 2x squared, positive 2x, but minus x. And negative 1 times 1, negative 1. So we have 2 critical numbers. One which is 1/2, and the other one which is negative 1. I'll stop to wait to see if you have any questions. Okay, I'll put them in the table. I will put 0 underneath for the first derivative, of course. And now I have to study the sign of this function. Remember, it's quadratic. It has a positive leading coefficient. The function, if I were to graph this, the function has a minimum. It's positive to the left of negative 1, negative in between negative 1 and 1/2, and positive outside. You don't have to do this. Just pick a number. Negative 10, plug it in. You're going to get a positive number. Plug in 0, you're going to get a negative number. Plug in 10, you're going to get a positive number. At this point, I should determine these 2 values. So for negative 1, that's not a problem. But for 1/2, I'll use the calculator. So f of negative 1 is negative 4 plus 3 plus 6 plus 1. So these go away, so it's 6. But to plug in 0.5, I'll just use 4, in parentheses 0.5, to the third power, and then plus 3 times 0.25, because 0.5 squared is 0.25, minus 6 times 0.5, which is negative 3, and plus 1. And I got negative 0.75. So f of 1/2, negative 0.75. Now, if I ask you where does this function go when x approaches negative infinity, and where does the function go when x approaches infinity, let me see, I have 20 minutes. Yeah, let me continue. I just need to break it up into smaller pieces because Monday night I was up till 1 a.m. to finish uploading. Okay, so can anyone give us the limit as x approaches negative infinity from this function? Limit as x approaches negative infinity from 4x cubed plus 3x squared minus 6x plus 1. And then as the limit as x approaches infinity. Can anyone give us this and then this? Anyone? Maybe you said it, but I couldn't hear it. Anyone? Degree is 3. All these don't count. Too small. Negative infinity to the third power. Negative infinity.
Negative infinity. Yeah.
Good. Perfect. So negative infinity and infinity. Good. So now this is the moment of truth. I need to make sure that these two rows work well together. Because if they don't, I'll say oops and go back to the drawing board. Okay, from negative infinity to 6, what does the function do?
Increases.
Right. Is that supported by the sign of the first derivative?
Yeah.
Good. From 6 to negative 0.75, what does the function do?
Decrease.
Is that supported by the sign of the first derivative?
Ease.
And again here. I can identify now the type of point negative 1/6 is, and 1/2 negative 0.75. Can anyone say what type of point is negative 1/6?
Local maximum.
Excellent. And this one is a local min. That is given by the sequence of signs. Positive 0, negative is local max. Negative 0, positive is local min. Positive undefined negative is still local max. Negative undefined positive will still be local minimum. It's not the case here, but I just wanted to refresh your memory. So now if I ask you, because that's the first question here, when is the function increasing? You will say from negative infinity, negative 1, union 1/2 to infinity. When is the function decreasing? Between negative 1 and 1/2. Is that clear? So you can even write that. I'm never going to ask you to write it. There is no need, because you're going to present this table or a table that you like, and it will be very clear to me. With all these arrows, it's very clear. So f increasing on negative infinity, negative 1, union 1/2 infinity. Notice that we are talking about trend. You cannot use the equal symbol here. And f is decreasing on the interval negative 1 to 1/2. The next question was find the local max and local min. We already did. I put them in the chart. There is a part C here, and we have to talk about it. Okay. We know what the first derivative is telling us about a function. It gives us max min, local max min. And it also gives us increasing slash decreasing intervals. So the first derivative tells us when the function has a local max, local min. And it also tells us when the function has an increasing or decreasing interval. I'm going to stop.